Okay, so today we're gonna learn the new chapter, which is chapter 4, individual and market demand. But this is our second topic, okay? Remember in chapter 3, we found one optimal point, but here is the real question. What happens to that optimal point when prices change, okay? Chapter 4 is about tracking that shift and then scaling it up from one person to an entire market, okay? Individual and market demand. Let's see the chapter outline, okay? The logic flow of chapter 4. First, we're gonna learn individual demand. The question is, how does my optimal choice change when price changes, okay? So what we are building here is the demand curve from the indifference curve and budget line model graphically, okay? So we need IC, indifference curve, and budget line model. Next one, 4.2, income and substitution effects, which means why does my choice change? Is it because I'm poor or because the good got relatively pricier? This is the question. And what we are building, we are trying to decomposing the price effect into two forces. Okay, so here we are trying to decomposing the price effect into two forces. And next topic, which is market demand. The question is that what if we add up everyone's individual demand? What will happen to the market demand? Okay, so the logic is from individual to market. Next one, consumer surplus. How much benefit do consumers get from being able to buy at the market price? Okay, so here we are talking about how to measure welfare and benefits in terms of money. The last topic, network externalities, okay? Does my demand depend on what other people buy too? This is the question. And we're building the demand interdependency, okay? Like the social media, the Line app. So here is about demand interdependence. This is the whole picture about chapter 4 and our second topic, okay? Okay, so here is the steps that we're gonna follow for your reading. Next one, let's move to 4.1, individual demand. Okay, so here is about price changes. Look at the graph. So the idea is that what happens when food gets cheaper? The information is here. Reduction in the price of food, which means price of food is decreasing, right? But the income and the price of clothing fixed. This is how we explain in economics, right? Ceteris paribus, holding other things constant, okay? So here we are caring about the price of food, which is decreased. And here we have two graphs, right? The upper part, panel A, how to read it. So price of food falls, right? Remember, we have the assumption here. Okay, so at first we're at point A, right? We have budget line here and indifference curve here. So we have our initial point, which is A. And then when price of food falls, what will happen to the budget line? Because this is fixed, but the price of food becomes cheaper. That means the budget line rotates outwards, right? From here to here, and then here. Remember, rotate outwards. Because if price of food decreases, that means you can buy more food, right? So here we have the budget line rotates outwards. So, and the individual here, he or she will find new optimal point each time. Suppose the optimal point is A, right? And then move to point B and then move to point D, right? And if we connect all optimal points from A, B, D, then we have the price consumption curve, okay? This is the price consumption curve. In abbreviation is PCC. Okay, this is the price consumption curve. Let's see the lower part, this graph. Okay, so the same information from above, and instead here we're gonna plot price versus quantity directly, right? And here is only about food. So basically point E is in terms of point A, right? And G is related to point B. So H represents point D, right? Because let's see the price. This is the price, right? The price of food decreases from 2 to 1. And then from 1 to half. So each time when the price changes, we're going to have different optimal bundles, right? So, and then when we connect E, G, H together, here is our demand curve. Okay, this is our demand curve. You see, point E, price is 2, the quantity is 4 units, right? And when price decreases to 1, the quantity is 12 units, and so on, so far as half, the quantity is 20, right? And then we have the demand curve, and it's downward sloping. I think you should be very familiar with demand curve, and which is downward sloping. It shows the negative relationship between price of that good and the quantity of that good, okay? So downward sloping. Okay, so the one that you need to take away is the price consumption curve, which is at the top, tracks optimal baskets as price changes, and demand curve at the bottom, the same story, just price versus quantity format. So we have, so PCC lives in IC world, indifference curve world. PCC lives in IC world, but demand curve lives in the real world. This is in the real world. How can we observe, okay? This is how to explain and how to read those two graphs. Okay, let's continue. So let's see the individual demand curve. So we have price consumption curve tracing the utility maximizing combinations of two goods as the price of one changes. Okay, we talked about it before, which is PCC. And then we have individual demand curve relating the quantity of a good that a single consumer will buy to its price. Okay, the individual demand curve has two important properties. The first one, the level of utility that can be attained changes as we move along the curve, right? And then at every point on the demand curve, the consumer is maximizing utility by satisfying the condition that the marginal rate of substitution, which is MRS, of food for clothing equals the ratio of the prices of food and clothing. It means that, let me explain it in plain English. The first property means that different points equal different happiness levels, okay? Different points means different happiness levels. The second property, every point consumer is still optimizing, right? At every point, which means, you see, maximizing utility, which means the MRS equals the price ratio that we learned in last chapter. So here we have price of food over price of clothing. Next one, we're gonna see what happens if income changes. Remember, what I just mentioned is about price of one product changes, okay? So later we're gonna see what will happen if the income changes. Okay, so let's see how we read those two graphs. So here we have a prerequisite, which is the income increase, right? The income increases, right? So the big idea is that what happens when income increases? Let's see the upper graph. Suppose point A is the initial point, right? We have income, this is our budget line. We have the indifference curve here, which is U1. Okay, so when income increases, what will happen to our budget line? The budget line shifts outwards, right? And parallel shift, okay? So here we have income increases, which means budget line shifts outward. And it's parallel shift, okay? Parallel. So here you can see from the inner budget line to the middle and then to the right. And consumer, right? Of course, if the income changes, we're gonna find our new optimal. So consumer finds new optimal each time. Okay, so we have A, B, D as yo-yo. And if we connect income, if we connect all the optimal points, we're gonna have income consumption curve, okay? This is income consumption curve. In short term, it's ICC. And in the lower part, we have higher income demand curve shifts rightward, right? Because here we have the income is increasing. So higher income demand curve shifts rightward. Okay, you see here, same price, which is $1, but can buy more food because the income is increased, right? So point E, the income is $10. Okay, you can find it here. $10, $20, $30. And then at point E, the food we are willing to buy, we're gonna buy is 4 units, right? And G 10 units and H 16 units. More income, of course, you're gonna buy more of everything. So the demand curve moves right from D1 to D2 and also to D3. Okay, so we just learned 2 new concepts, right? Let me add the page. The first one is price consumption curve, okay? And then we learned about income consumption curve. What is the difference? Let's see. So PCC, which in figure 4.1, and ICC is in figure 4.2. What changed, okay? And how about the budget line? What will happen to the budget line? And what is the result? Okay, so for PCC, of course, the price changed, right? The price changed. And the budget line will rotate, okay? Rotate. This is rotate. The result is demand curve, right? We're gonna have demand curve. And we're gonna have one demand curve, right? Let's see, let's go back here. We're gonna have one demand curve. It's just, so if price changes, it's just the movement along the same demand curve, right? Upward, downward, but always in the same demand curve. This is price changes. Next one, if income changes, right, which is ICC. So here is income, I just use I. So you should be familiar with those abbreviations, right? P means price, I means income. So if income changes, the budget line will shift outwards parallelly, okay? In this case, what will happen? The demand curve shifts right. Okay, this is the difference between PCC and ICC. Okay, so let's continue. Okay, here we're gonna talk about normal goods and inferior goods. Okay, what is the difference? So let me give you some idea and also example first. So basically, this is about slide 6. The idea is that not all goods behave the same when we have more income, right? So not all goods behave the same when income rises. Okay, so here, if income increases, okay, We have two kinds of goods. Normal good. What is the other one? What is the opposite of normal good? Bad good? No, inferior good. Okay, so here, if income rises, if it's normal good, it means we're gonna buy more, right? Because it's normal. One example is steak, right? Let's say steak. So for inferior goods, if our income rises, we're gonna buy less because it's inferior. What is the good that if you have more income, you're gonna buy less? Can you give me one example? Yeah, cup noodles. ชอบกินมาม่าไหมคนไทยอ่ะนักศึกษาไทยชอบกินมาม่าไหมชอบเหรอ So if you have more income, you're gonna buy more. That means it's normal good for you. How about the other people? If you have more income, will you buy more instant noodle? If you have more income, if you are getting richer and richer, will you eat instant noodle every day? Maybe not, right? Yes.
But it's just preference.
It's just breakfast.
Yeah.
Okay, but it's not healthy at all if you eat it every day, okay? So basically, for cup noodles, okay, instant noodle, we for normal people, okay, you are exception. For normal people, it's gonna be inferior good. Okay, so here I talk about the difference between normal good and inferior good. Let's see the graph. What is this? This figure shows an inferior good. Why? Okay, the logic trend is we are moving from point A to point B and then to point C, okay? From A to B and then to point C. What happened? Point A, which means the income is low, right? And here we have steak and hamburger. Okay, so here, when our income is low, our optimal point is 5. So here we're gonna buy 5 hamburgers and 3 steaks, right? So here actually we are testing what kind of good about hamburger. Is it normal good or inferior good? Okay. And then when our income increase to medium, so our budget line gonna shift parallel outwards, right? And then we have our optimal, which is point B. So here we actually buy more hamburgers, right? From 5 to 10. Okay, so from 5 to 10. Of course, this means that more income, we buy more hamburgers. So this means hamburger here from A to B is a normal good. And let's see what happened next. And then our income kept increased. Okay, so so now we have a new budget line. So maybe I need to write down here. This is budget line 1, budget line 2, and budget line 3. Okay, so in this case, we're gonna move from point B to C. See here, actually we're gonna buy just maybe around 8 hamburgers, right? Just 8 hamburgers. So basically B to C is like this. Moved left, okay? That means from A to B, the hamburger is a normal good. But from B to C, the hamburger becomes an inferior good. Okay, and then we connect the optimal points. We have our income consumption curve, which is ICC. Have you noticed that here, ICC bends backward? Okay, this is ICC, bends backward. So this is the signal of inferior good, okay? So ICC here bends backward, which is a signal of inferior good. Okay, so be careful, from A to B, hamburger is still normal. It's still a normal good. But from B to C, hamburger becomes an inferior good. Okay, let's continue. Let's see the angle curve. What does it mean? The curve relating the quantity of a good consumed to income. So here we have 2 angle curves, right? Angle curve relates to the quantity of good consumed to income. In the upper part, which is A, food is a normal good and the angle curve is upward sloping. We have food on the x-axis, right? And in A, the angle curve is upward sloping, which means food is a normal good, right? And in B, however, hamburger here is a normal good for income less than $20 per month. And then it becomes an inferior good for income greater than $20 per month. So if you get richer and richer, you're gonna buy less of that good. Okay, so we call that good is inferior. So here you need to distinguish. So actually here is our threshold. Okay, so the income equal $20 is our threshold. Less than 20, you buy more, it's normal. If you are richer, greater than 20, you're gonna buy less, which is inferior. The inferior good means richer you get, less you buy it, okay? Because you upgrade. For your rating, those 2 examples. Next one, we're going to talk about the substitutes and complements, right? If we say that 2 goods are substitutes, if an increase in the price of one leads to an increase in the quantity demanded of the other. Because they are substitutes, right? Actually, they are compete with each other. And if we say that 2 goods are complements, which means that if an increase in the price of one good leads to a decrease in the quantity demanded of the others. So here we combine them to consume. Can you give me one example of substitute? Two goods, they are substitute. Do you drink Coke? Okay, so what is the substitute of Coke? Pepsi, Sprite. Okay, so let's see, Coke and Pepsi. So they are substitutes, all right? How about complements? Petrol and scooter, right? They are complements. You need to consume them together. And if two goods are independent, which means if a change in the price of one good has no effect on the quantity demanded of the other, so here, which means that two goods, they don't have any relationship, right? So here, the fact that goods can be complements or substitutes suggests that when studying the effect of price changes in one market, it may be important to look at the consequences in related markets. Or we can see that here is about cross price effect, right? Because we have two goods. So the idea is that if price of good A increase, what will happen to quantity demanded of good B? Okay, so if they are substitutes, that means quantity of B rises, right? So in this case, the change of quantity of good B over the change of the price of A is greater than zero. So we call them substitutes, okay? The other way around, if the change of quantity demanded of good B over the change of price A is less than zero, so they are complements. And if the change of quantity demanded of good B over the change of price A, they are equal zero, so we say they are independent. Let me show you the logic chain step by step. Okay, so we have substitutes. Which means goods that compete for the same need, okay? Which means if price of A increases, so A becomes relatively expensive, right? Because the price of A increased. So in this case, consumer switches away from A. And then they're gonna buy more of product B. So the quantity of the product B will increase, okay? So that's why, you see, we have here the change in quantity of B over the change of price A is positive. This is substitutes. So if the price of Coke increases, what happens to your quantity demanded for Pepsi? If the price of the Coke increases, you're gonna buy less of Coke, and then you're gonna buy more of Pepsi. Right? Next one, complements. I'm gonna show you why the sign here is negative, right? It's less than 0. Complements, they are goods that we consumed together. So here, price of A increase. Consumer buy less of A, right? That means they also need less of B. Because we use them together. The consequence is that the quantity demanded of product B will decrease. Okay, so you see one increase, another decrease. So that means they move opposite, okay, which is negative. Another type, independent, which means no relationship. Okay, so we're gonna have 0 here. Okay, so price of A increase, and there's no link to B's usage. So maybe the quantity demanded of product A stays the same. Let me give you example. Okay, so suppose the price of motorcycle helmets rises. Okay, motorcycle helmets. So there's no effect on demand for mango sticky rice. Okay, so we can say that the motorcycle helmet and the mango sticky rice, they are independent. We can't say that they are substitutes or complements. And why does this matter? Because the markets are connected, right? A price shock in market A maybe will have the spill effect to market B. Okay, this is how we study the influence of two markets or different markets. Think about if the price of gasoline increases, okay? So the quantity of motorcycle will decrease. Example here. So price of gasoline increases. Let's see, the quantity of scooter decreases. So in this case, they are complements, right? And the other way around, if price of gasoline increases the same, let's see the quantity demanded for electric scooters will increase. So in this case, the gasoline and the electric scooter, they are substitutes, right? Anyone use a electric scooter or EV car? Okay, so we'll use the traditional one. Okay, traditional scooter. This is about 4.1, okay? So let's move on to 4.2, income and substitution effect. So here we have 4 in the price, okay? Price falls. Okay, a 4 in the price of a good has 2 effects. The first one, consumers will tend to buy more of the good that has become cheaper and less of those goods that are now relatively more expensive. This response to a change in the relative price of goods is called the substitution effect. The second one, because one of the goods is now cheaper, consumer enjoying an increase in real purchasing power of your money. The change in demand resulting from this change in real purchasing power is called the income effect. Okay, about those 2 effects. Okay, let me give you a short version, okay? Substitution effect, which means this is now cheaper than others. Okay, so you're gonna swap. So this is substitution. So you switch to the cheaper one. The income effect means I feel richer now because of the purchasing power, so I'm gonna buy more. Okay, so here we have a formal definition of substitution effect and income effect. Let's see it one by one. Change in consumption of a good associated with a change in its price, with the level of utility held constant, which means the same happiness but different price ratio. Because here we are holding the level of utility constant, right? So which means the same happiness, but different price ratio. And normally we're gonna swap to cheaper one. How about income? Income means change in consumption of a good resulting from an increase in purchasing power. with relative prices held constant. So here, same price, but I feel richer. So I'm gonna buy more overall. Okay, next one, we're gonna look at figure 4.6. The total effect of a change in price is given theoretically by the sum of the substitution effect and the income effect. Okay, so we have a formula here. The total effect equals the substitution effect plus income effect. Let's take a closer look at figure 4.6. So here we have normal good, okay? Can you see this one? This is normal, okay? Normal good. How to read this graph? Okay, so here we assume that a decrease in the price of food, right? A decrease in the price of food, and then the budget line gonna shift, gonna rotates outward, okay? Okay, so let's go step by step. Here at first, the consumer is initially at point A, okay? Because we have budget line here, we have our utility, which is U1, IC curve here. So point A is our initial optimal point, right? It's on budget line, RS. So the first one, if you are asking to draw the graph, you need to draw the budget line, which is RS, with indifference curve, which is U1, and those give you the optimal, which is point A, okay? And when the price of food falls, so basically your budget line gonna rotate to RT, right? And then RT, this one, RT, okay? Because the price of food decreases, okay? In the new budget line RT, you're gonna have the new indifference curve, which is U2. And this gives you another optimal, okay? A new optimal point, which is B. But how come we have a point D here? Why we have point D here? This is how we separate substitution effect and income effect, okay? From A to B. So let's see in A, the food that we consume is F1. And at point B, the food we consume is F2. So from F1 to F2, this is the total effect, okay? This is the total effect. But how we can separate the substitution effect and income effect? So here is the trick. We need to draw an imaginary budget line which parallel to the new line RT, parallel to the new line RT, but tangent to the old indifference curve, which is I1. So that's why we have a light, Can you see light blue budget line here? So this line is our imaginary budget line, okay? So this gonna isolate the same satisfaction because we tangent to U1, but now we have new price ratio. This imaginary line touches U1 at a new point, which is D. So at D, we're gonna consume the amount of E units of food. So in this case, we can now break down the substitution effect and income effect because we are holding utility constant, right? So you see, along U1, we have point A to point D, which is F1 to E. So this is the substitution effect. And then from D to B, this is actually income effect. I know it's quite confusing, so I'm gonna draw the graph step by step, and then I'm gonna show you, okay? So let's do it. So here we have two goods. I'm gonna use the blue line. You should be able to draw the graph, okay? So we have food, right? We have food on the x-axis. And you have to know which line you should draw first. Otherwise, you just get confused. And on the vertical axis, we have clothing. So suppose the initial is that this one. Okay, this is our budget line 1, right? This is our budget line 1. And at this budget line, I'm gonna buy. So I need utility IC curve. So this is our IC1, okay, utility 1, which is U1. Here is point A, okay? Point A, we consume how many of food? F1, right? So basically, I just follow the example. So when you review the teaching slide, you will not get confused. But I'm not sure now, are you still awake? Are you still awake up about this example? Okay, initial point, which is A. Next one, don't forget our prerequisite is that the price of, okay, normal good, this is normal good. The price of food, what happened? The price of food decreased, okay? The price of food decreased. If the price of food decreased, that means my budget line gonna rotate outwards from blue to yellow, right? Because I can buy more food. So this is my budget line 2. And in the new budget, of course, I need to change my optimal consumption, okay? So here I have a new IC curve. So U2, right? And here we have our new optimal consumption bundle, which is B. So here in B, I consume F2 units of food, okay? So from A to point B, or F1 to F2, this is the total effect, right? This is the total effect. How to separate or decompose the substitution effect and the income effect? Remember? for substitution effect, we should be in the same utility, right? The same happiness. Okay, look at the definition of substitution effect. The same happiness. That means we're gonna draw an imaginary budget line. Okay, BL2, and then draw a budget line which is parallel to BL2, and then you move it until you tangent the utility 1. Okay, this is how we find the substitution effect. Okay, so let's try it. The line should be parallel to budget line 2 and then tangent to U1. Okay, so the pink line is the imaginary budget line. Okay, the imaginary budget line. Here, in our example, it's the light blue line. Okay, it's the light blue line. But here I use pink. So here I'm gonna have a new point, right? So, but basically we cannot observe this point because it's our imaginary. Okay, it's our imagination. So here's D. Okay, so at point D, I'm gonna consume E unit of the food. Okay. You should be aware that why I draw this graph step by step to you, okay? For your better understanding, okay? So let's decompose the total effect. Because, okay, so from A to D is, which means from F1 to E. We call this effect is substitution effect, right? Because we are at the same utility level, okay? We are at the same utility level. So from A to D is the substitution effect. And then from D to B. Or let's see, from point E to point F2. This is the income effect, right? This is the income effect. So basically here, we decompose the total effect from A to B, from F1 to F2 into two parts. The first one, F1 to E is the substitution effect, and E to F2 is the income effect. And next one, let's draw the demand curve for food, okay? You have to draw the same coordinates. In this case, on the x-axis is the quantity of food, but on the vertical axis is the price of food, okay? So because we are talking about the demand curve, okay, it's always the relationship between the price of that good. And here we are assuming that the price of food decreases, okay? So let's see, before we have a price, which is P1 equal $2. And then we have our new price, which is P2, which is maybe $1. And let's connect. Okay, so you draw the dashed line first because we have two different prices, okay? And don't forget our prerequisite is that the price of food decreases. That means the price of food drops. Okay, so here we have initially it's here, right? The initial optimal is point A, which I buy F1 unit of food. So here I got one intersect, right? And next one, the price decreases. So right now my optimal is at point B. I buy F2 units of food. So I got another new intercept, right? The blue one is the initial one, which is point A. And the blue one is the point A, the yellow one is point B. So 2 points, we can find one line, right? So here I have. So I just connect it. This is the demand curve for food. Okay, I'll give you 5 minutes to review about this graph, okay? How did I draw it? Okay, I'll give you 5 minutes and then after that, I'm gonna summarize for you. So please think about it. So the scenario here is that we have a normal good. So food here is normal good. Okay, so let's take a look at normal good. Okay, so basically we have three effects, which is substitution effect. I use S dot to represent substitution effect. The substitution effect, the direction means that food increase, right? Always. Why? Because the price of food decrease, that means it becomes cheaper. Because right now food here is cheaper good, so you always buy more regardless of good type. And for the income effect here, the quantity demanded for food increase as well because it's a normal good. Okay, so this means lower price, which means more purchasing power. So you're gonna buy more of a normal good. So we have the total effect, which means the quantity demanded for food increased more. So I use two arrows to represent the total effect. Because the both effects reinforce each other, okay? Increase and increase, so we have double increase here. This is why normal goods have clearly downward sloping demand. Look back to the graph, okay? So from F1 to E, this is a shift from point A to point D at the same utility level, which is U1. So here is our substitution effect. You can also check by the official graph here, okay? So this is substitution effect, okay? It's increase. And then from D to B, which is from E to F2, it's increased as well, okay? So increase plus increase, which is double increase. That's why we have our total effect, which is A to B or F1 to F2. This is our total effect, okay? A large increase. And then we can draw the demand curve for food. Here, right, it's a clearly downward sloping. This is clearly downward sloping. So guys, please, you have to know that how to draw those two graphs. Okay. One at the top, another one at the bottom. You have to draw it and it's connected with each other. Okay. Point A is here, point A, right? Same F1. Okay, same quantity demanded for food. And then point B. This is point B, this is F2. So the pink line, what is the pink line here? Remember, what is the pink line here? What is the pink line here? It's the imaginary budget line, okay? We cannot observe it in the reality. We just image, okay? You just imagine. That's why we draw it. In order to decompose the substitution effect and income effect. Okay, so today we talk about the demand curve for normal good. I hope you review it, okay? Because there's no homework for this week, but I might make a recording for you. Like next one, I'm gonna talk about the next good, which is inferior good, okay? So here, inferior good is totally different. I so on the weekend, I may record a video for you, and I'm gonna explain the inferior good, how we get this graph, how to get the demand curve for inferior good. I promise that it may be just maybe 20 or 30 minutes. I'm not sure. Because for my other courses, like econometrics one, I also made a recording for them. So basically, I couldn't cover all the content that I want to in the class. That's why I have to make up virtually. Any questions about the normal good? Any questions? Okay, so be careful about the price here, okay? Is it decrease or increase? Students always get confused about those two. If you make those two incorrect, you're gonna have different points, okay? And then of course different demand curve. If no question, I'm gonna see you on next Monday, all right? So be expected about the upcoming recording. No homework, but you may have to watch the recording, all right? And it's the new one, not about what I covered today. So thanks for coming and see you next Monday.